This tutorial introduces how to use pspice to simulate digital circuits. Specifically, we will use the exclusive OR circuit as an example. This is a schematic. Two main types of basic components are included. The first is 7400 series logic gates. Basic logic gates include 7404, an inverter, 7408, two-input AND gate, and 7432, two-input OR gate. Just like analog circuits, digital circuits also have the input signals. And in digital circuit, the input signals are represented by digital clock, or sometimes digital clock stimulars. Those can be found in the source library.
Now let's see what we can do in pspice. If we go to the eval library, you may find all of those basic logic gates, such as the inverter. We may place the part onto the schematic. Go to the source library. Digital clock can be found from the part list.
We could make this a simple digital circuit by wiring those two parts. Double-click on the digital clock stimulars to change its attributes. On time is a time period for the signal being digital 1, and off time is the signal being digital 0. Put a marker for the input signal and change the transient parameters to show only a few cycles. The file also needs to be saved before running the simulation. Here comes the simulation of the stimulars. Both the off time and on time are half macro, and one full cycle is 1 macro. Now let's see how the inverter works. Let's put a marker on the right side of the inverter and run the simulation. The result is showing as the second line of the signal, and we can see that it's inverted from the stimulars.
As for exclusive OR, this is the truth table. From the truth table, we may derive the expression is as follows. The result is 1, or digital high, when the two inputs A and B are different. Otherwise, it's 0. That is AB naught plus BA naught. At this point, we've got all of the knowledge we need for building the circuit in pspice. We use one stimulus for signal A, and the other is signal B. This inverter will bring us B naught, and this AND gate becomes AB naught. This is A naught, BA naught, and eventually the final OR gate will give us AB naught plus BA naught.
This is a sample schematic as well as stimuli setup. In our design, the frequency of signal A is half of signal B. Let's first check out the input signals to see if that's the case. Everything goes fine so far. Now we may add the output signal. The simulation result shows the exclusive OR circuit is working as expected. When both the input signal A and B are equal, the output is digital 0. Otherwise, it's digital 1.